Good morning, everyone, and good afternoon to our friends on the East Coast. Thank you so much for joining us today. We are ready to get started. We have a jam-packed webinar for you, so much information, so we will get started right away. Just to make sure that this is as useful as it can possibly be to you guys, before I introduce Ping and Greg and they take it away, I wanted to get a bit of an idea of how experienced a lot of you are. So for starters, in that chat in the sidebar there, if you can let us know when you open up Wireshark, what's the situation you're usually facing? What's going on in the background that's causing you to then go in and open Wireshark? You can be very specific or general. We'll take either. And then while you're doing that and thinking about that, we're also going to pop a poll in here. So we want to know, as usual, for those of you who have joined us on webinars before, we like to know who you are. We want to know if you're an integrator, a building operator, a consultant, a manufacturer, or someone else. And if you're someone else, let us know who you are in the chat as well. And that just helps us make sure that our examples and all the information we're sharing is as relevant as possible. So while you guys are filling that out, I'm just going to read through, for the benefit of Ping and Greg here, some of the answers as to why people are using Wireshark. So problems reading the object list from Jürgen, thank you. Also, ICMP errors and timing issues. Mike says that usually it's an integration issue with the product. BACnet network issues from Russ. Zach says join captures to generate data for troubleshooting and documentation, usually looking for a specific thing, so some kind of specific bug, I'm guessing. So let us know anything else that you are using Wireshark to find, and also let us know who you are. So I think we'll close that poll. Got a good response there. Primarily integrators and contractors, with quite a few consultants and manufacturers here as well. But don't worry, building operators, engineers, we won't forget about you. And the other, we'd love to know who you are. Share that with us in the chat. And then we're just going at a quick pace today. One more quick poll for you guys. So we're going to pop that in, and we want to know what Wireshark functions you are familiar with. So these are all things that we're going to be looking at today, but we want to make sure that we spend more time on the ones that you're less familiar with, and we don't bore you with the ones that you know a lot about. So get that response in there. And anyone else has any other reason that they are opening up Wireshark, please share that. All right, 50% of you have voted. We need better from you. While those votes are coming in, I will just let you all know, as per usual, that this is being recorded. So you'll be able to have access to it later. We also have a bunch of the files that Ping and Greg are going to be working through today. A lot of them have been made specifically for this webinar. Greg has set up his network just with some specific issues, and so those files are available to you. You can see them. There's a handout, and in that handout there's a link to our Google Drive folder with those files. We've also put that link in the chat. And if either of those isn't working for you, just send us a message and we can send you that link directly. Also, as per usual, we are open to tons of questions. So if you have questions and comments throughout this, don't be afraid to share them. We also are very open to other people's ideas. We know we have some really experienced people out there. So if you have other comments on what we're talking about or other tricks that you know with Wireshark, please let us know. We'd love to share the expertise. So one more response here. Terry says lottery numbers. Okay, so Wireshark functions, most people are fairly familiar with filters, as well as some are familiar with colorization, conversation lists, and graphs a bit less. But don't worry, by the end of this, you will all be familiar with all of those. So I'm done speeding through my intro. I am going to let Greg and Ping take over. I'm actually just going to duck out of the screen here completely. But I'm really, really excited to have the pleasure of introducing our CEO and founder, Pook-Ping and Greg Holloway of Delta Controls. I have a huge amount of respect for what both of you can do and your knowledge, and I'm really excited to share that with our webinar guests. So Ping, I'll let you take it away.
Sure. Thank you, Monica.
Thanks.
All right. As Monica said, we have a jam-packed schedule, so let's dive right into it. Today we'll be talking about advanced troubleshooting BACnet with Wireshark. We did some polls very quickly. What we're going to be looking at, a quick welcome note. We'll look at some of the, we're going to review a few basic or more advanced Wireshark functions for about 5 to 10 minutes, and then we're going to go into actual BACnet issues. So Greg and I have prepared a few files with issues like circular network and duplicate BBMD. We'll go over it, see how we can use Wireshark to find these issues. And then finally, we're going to wrap up with a few additional Wireshark tricks and then open up a few questions and answers. So again, a lot of material. So let's keep going. Again, thank you very much for your time. Greg, you want to say a few words about who you are?
Certainly. Thanks, Ping. My name is Greg Holloway. I'm with Delta Controls in Vancouver, British Columbia, Canada. And I've been involved with the company in a number of different forms over the years, and it's now up to 23 years that I've been connected with Delta. And of that time, for the last 18 years, I've been one of our BACnet guys at the company. I'm not actually a developer, but my role is to support our distributorship network that we have at Delta around the world. So when our people out there in the field are having problems with BACnet interoperability problems and traffic problems and all those sort of network problems, I'm one of the people at Delta Controls that they would contact for assistance and help. So for me, Wireshark is kind of an old hat thing because I use this tool every day in my role, and that's been true for many, many years. So it's given me a lot of insight into different problems that occur frequently in the BACnet world. And that's why Monica asked me to join this webinar. So thanks, folks, for joining us.
All right, Greg, let's take this right into Wireshark now.
Okay.
As I said,
up with the slides, right?
Yeah, that's right, enough with the slides. We're going to open up one Wireshark file that Greg prepared for us. It's artificially made in this case. And by the way, if you don't have access to the files right now, I think you can go to handouts right within GoToWebinar, and you should be able to get a link to it.
Yeah, we made the files available to you folks so that if you wanted to review some of what we cover here in the tool yourself, you would have a sample file you could use. Most of these I generated in a test network that I have, so there's nothing secret in them or anything like that. They're not from a real project. So, okay, so Ping's open up this file. This one here is a good example case for a BACnet IP network. So what we're talking about here is we have a capture file that I created where BACnet IP is in use. So we're not just talking about BACnet Ethernet packets. But the trick of it is that this particular network is using UDP port other than 47808. So 47808 is the default BACnet port that we would use. And this particular capture is using a second port. And this happens a fair bit when you're setting up more complicated networks. So yeah, things open up the spot. Yeah, okay, good idea.
I'm going to show what it looks like by default. Yeah.
Right. So you can see how there are 3 lines highlighted in blue there that just say 49,000 in info, and they don't really look like they're BACnet packets, but they are. And so we need to tell Wireshark to decode, in this case, port 49,000 as if it were BACnet. So go ahead, Ping, you can do the mechanics there. He's got his hand on the mouse. So then we right-click on the packet and hit decode as. And this is something for those of you who've used Wireshark for years, this is something that is vastly improved in version 2 of Wireshark. It used to be you could only have one other port, which was a pain really. So what this little dialog does is sets up a table for us where we can define custom ports for protocols on non-standard ports. So it's already filled in as UDP and 49,000, and all we need to do is change that drop down at the right current for which protocol we want to actually attach this to. Now, this has got a bit of a trick itself if you've never done this before. The obvious thing to pick would be BACnet out of this list, but that's actually wrong. The correct selection is called BBLC, which is BACnet Virtual Link Control. It's a upper level mechanism used for BACnet IP communication. So go ahead and pick that, Ping, and then if you're going to use that port over and over, then click Save, because that way every time you open up Wireshark, it'll already know that port is something that you're going to run BACnet on. So as soon as you hit that, it's going to go through the whole capture again. And this time you'll see how those three blue lines say unconfirmed request who is with an address range specified in there, because Wireshark now knows what those actually are. So just as a recap here quickly, during the poll session that we did, it indicated that a number of you have used the display filters before. Just for those of you who haven't, and maybe just to whet the appetite of those of you who have, but not necessarily to their full capability, the display filter is that white line looking for us to type in there at the top of the packet list where it says apply display filter. And this is, yeah, exactly. Go and set that to the, you might as well pick who is there, Ping, because that's something we got on the screen right now.
Yep.
So the display filters are tremendously useful because the problem is, and then hit the little arrow at the right-hand end of the line. So, okay, it's scanning it. Yeah, okay. Okay, good. The display filters are tremendously useful because typically when you're doing a network capture, you will end up with way more packets than you could ever manually look at. This capture I have, which is not very long, contains at the very bottom line, the status line, it says there's 18,872 packets. Nobody's going to look through every one of those manually. You'd be there forever. So the display filters allow us to basically temporarily throw away packets we're not currently interested in. So with this filter we've put in there, we've got displayed 4205. Yeah, and Ping's off and typing here. Are you going to do IM as well or something? Yeah, exactly. So, right. So basically, we can specify subparts of the BACnet protocol here. So what we're looking in this case for is who is packets or IM packets, which tend to clog up networks, really. I mean, they're very useful. They have a purpose, but if they're overdone, they tend to clog up networks with too much traffic. So if you're in the camp of someone who's looking to bring down the traffic volume on your own network, then this is a good place to start at. And you can see how we've already reduced the number of packets we have to look through here considerably from where we started. We're only showing 23% of them right now, which is good because obviously you don't want to look at them all one by one. So that's a display filter, and there is a lot more capability there because we can read other component parts out of the packet, and we'll illustrate that as we move into different capture files in terms of why you'd want to use that or how you'd want to use that. The one thing I will point out though is, hey, Ping, can you click on the expression button at the end of the line there?
Absolutely.
Yeah, so the thing about it is, how did Ping know what to type? Like, he typed that in there because he's done it a million times, but how did he know that? Well, if you hit expression, you get a big long column list of every protocol Wireshark knows. And if you look at, yeah, you can see how he's searching. If you look under back app, you will find all the little sub-elements of a BACnet protocol application. So this is APDU components. So Ping was clicking on unconfirmed service there. And if you click on, yeah, even there, it's got a list of all the BACnet vendors in there. So if you click on one of these, the right-hand pane will give you the syntax of what are the possible choices. So like Delta Controls, my company, is vendor number 8. So if we put that in there, it'll add this to the filter line we already have. Yeah, and then apply. We're going to get, I would think at least, yeah, we're going to get at least some stuff. These particular packets are Delta proprietary, but the point is that Wireshark was able to pick those out. So this is just kind of one of those funny cases of a filter. So the point of all of this explanation is that almost anything inside the packet, from the IP address, the MAC address, stuff like in BACnet in the NPDU, like the DNet, the SNet, DADDR, SDADDR, those can all be used as filterable criteria, plus all the APDU components that Ping was just displaying there, so that we can basically look for a needle in a haystack a lot more effectively. So the reason why we want to show this is because it's useful just to cut the packet list down, but second of all, it leads into another couple of areas here, which are the colorization capabilities in the display. And graphing as well. So this was something that was indicated as a little bit less familiar. So why don't you go to the colorization rules thing and we'll show how that works. So in the edit menu here, there's an option called coloring rules. Pick the coloring rules there. Yeah, that's the one.
Yep.
And it opens up another dialog where we can customize it. Now this list that's in here, this comes from Wireshark. Everybody's got this by default. That's why those UDP lines are blue, because this list is what tells it to do that, and you can turn them on and off. Most of these are standard IT type protocol stuff. There's nothing in this list that's really BACnet specific, and that's understandable because BACnet's just one component part of what Wireshark can do. But it's missing a lot of the niceness of this, because if you set up rules which use the exact same syntax as the display filters, you can basically have your packets, you can basically have your packets, you can call that delta packets or something. Yeah, sure, delta controls. Change the color so it's something obvious. Our color is red, so put red in there somehow. Company color thing. Yeah, that'll work. So what'll happen here is those packets that are now delta specific, you'll notice they're all in red, the text. You can change the background color on them as well, and it makes them stand out. And additionally, the slider bar at the right-hand end of your packet list will actually put little horizontal division lines in there when the colors are coming up where you're going to be able to find something that matches. You see how there's greens in there? Those are the ones that Ting has just defined. So anywhere where we see greens, it gives you a sort of an indicator on where to slide to in the entire capture. So very useful. And because in my case, I set these up years ago on my own computer for doing various BACnet tasks, because it's very, it makes reading the whole thing a whole lot easier. What I did is I saved out my coloring rules with the export button, and if you hit import on your Wireshark, you can import my rules. Now, these rules are, they're in that list of files that you can get from that Google Drive link that Monica shared at the beginning. So if you want my rules, then just go and grab that and hit open. Now, the only trick of this is that when you import, it adds it to the bottom of the list of existing ones. So yeah, what Ping's done here is good. He's basically unchecked all of the standard ones that are in there so that they don't get in the way. Because if you have, well, too many is not the right word. If you have conflicting entries, the first one will win. So my rules being at the bottom means they won't do anything. So you can either disable the first set of rules or you can just delete them. I have all the standard Wireshark ones in my list anyway. So go ahead and hit OK there, Ping.
Yep.
And then this is how they look to me. Now, my color scheme, you may say it looks awful, but we're not looking at particularly good packets right now. The red ones are global broadcasts, and the white ones are unicast directed messages, and the purple ones in there are local subnet broadcasts. So I can tell at a very quick glance where are the packets going in terms of their destination in BACnet. So if I'm looking for a traffic volume issue, I know sort of where to zero in on. And we'll see this in one of our captures we have coming up. In fact, why don't we switch files here over to the circular network one, Ping? Does that make sense?
Absolutely.
Yeah, so this is so let me explain the background of this file before we get into doing any analysis on it, because it's sort of foredrawn the conclusion based on the file name. In BACnet, what a circular network is when you have two or more paths between the same controller. So you have like controller A, controller B. It's as if you had two wires between them. You could do that with Ethernet and MSDP, but that's very rare for that to happen. But the common problem case is when you have two controllers and both of them have BACnet Ethernet turned on and BACnet IP turned on. So you've created in one Cat5 wire, you've created two BACnet paths between these controllers. And this is a disaster in BACnet because it causes what's called a circular network. Because broadcast packets that get into this ring, they get in there and they go round and round and round between the two devices that have both protocols enabled like this. and it chews up so much network bandwidth that your network just slows to a complete crawl. So this is just a disaster BACnet-wise. So this particular capture I have, I created a deliberate circular network during the capture. So let's say that your premise or your theory is, hey, I might have a circular network here. That's why my network is so slow. You'll notice how with my color rules, notice how much red there is in this thing. To me, red is bad. That's the color. Now, the way you find a circular network is using the display filters. So go up to the display filter there, Ping,
Yep.
and we'll put in the BACnet.hopc. Yeah, exactly. And then just put like less than 10 or something or whatever. Yeah, that's fine. And apply that, and we should still get some entries. Okay, what this filter is doing is BACnet broadcast packets have a quantity in them. In fact, can you open up, yeah, exactly, open up that MPDU. They have a quantity in them called hop count. This is similar to IP's time to live, TTL. Basically what it is it's a number that starts out at 255 when the packet is transmitted. Each time it goes through a BACnet router, the number is decremented by 1. So that number is dropped by 1, and it drops and drops and drops. And if the value ever gets to 0, you want to say something?
I just want to show a little trick. If you
go ahead.
If you open up
you're
the display,
you're gonna make it a column, aren't you?
Yeah, I'm gonna make it a column. Yeah, just to show it. And
yeah, then we can see the number going down.
Yeah, I'm gonna remove the filter, and you can see it counting down.
You can see the number is bigger and then getting smaller, and if he scrolls up, it'll be bigger still because the number started out at 255.
That's right.
Yeah, so the number is climbing if you go up. There are multiple packets interspersed here. That's why the numbers jump around a little bit. So basically, in our circular network, each time it goes through that loop, the number is going down by 2 because it's going through both sides. And the idea behind the hop count is basically a way to prevent disaster. So when it gets to 0, the packet's thrown away. But it has to be bounced back and forth that many times before it can be thrown away. That's why it causes so much trouble to networks, is if you have a circular network. So the thing of it is if you have a circular network, the hop count value is invariably going to be falling a lot. And that's why we put in there 10. Because basically in the circular network case, the value is going to fall all the way to 0. So if we look for packets on the network, which is what BACnet.hopc does, that have a hop count less than a small number, if any packets come up, then you basically have a circular network.
Yep. So Greg, I'm just going to summarize what you just said there. So if you suspect
Go ahead,
if you suspect a circular network, one easy way to look for is if you have a lot of broadcast. That can be one kind of the first hint of it. Then you use the filter as Greg said, which is BACnet.hopc, hop count, less than a small number. It actually really doesn't really matter what number you use. You can use 50.
It could be 100 or something, and it would still work fine.
That's right. And then what you can see here is that just like what Greg said, you have the same device. So I'm just going to filter based on this device. By the way, another trick, if you look at the field, you right-click on it, apply as filter, it will just do that right away. So that's the new way.
Yeah, right, the display filter for you, basically.
Yeah, and you can see here, the same device has BACnet over Ethernet and BACnet over IP. It's the same device that's causing the loop in this case. And again, you can see the hop count actually going down, 17, 16, 15, so on and so forth. When it reaches 0, the packet itself dies. The last router that reaches count 0, it discards that packet.
Right. So basically what you do in a case of finding a packet or a circular network is you look through one of these ones that's being duplicated and look at the MAC address source. And you're looking for who is actually sustaining this loop. What's causing this to sustain and go round and round and round endlessly, basically. So you want to look at the MAC addresses. Now, right now, Ping's got that filter in there that basically only shows us the one device. Go back to the HOPC less than 10 there, Ping.
Sure.
Because right now we're only able to see, we got to put BACnet. Yeah, perfect. So if we look at the source there, you're going to see that there are two different, notice that there are two different MAC addresses in the list. These were Delta devices that I set this up with, so that's why they're 0040AE, that's our MAC prefix, but 006760 is one of them and 010046 is the other one. If you were to scroll through the whole capture, you'd find those are the two very talkative guys because they're the two devices that are sustaining the circular network. So in this case, the way to solve it is you need to go to one of the two devices and disable BACnet IP or Ethernet, depending on what your design calls for.
Yeah.
So it's basically a misconfiguration of the network, and we're using Wireshark to find out or verify that, yes, this is the problem, and then we're going to break the link or the loop.
Yeah. I just want to show another little quick trick in Wireshark.
Yeah, you can see them right at the top.
Yeah, that's right. So these two here.
So what Ping's got open is the conversations list here. And so we've got all of these MAC addresses that are on the network. But notice that the one with the most bytes and the most packets are right at the very top. Those are the two guys I just identified from the main capture as the ones sustaining the circular network. Because if there's a circular network going on, there has to be two devices at least that are going hyperactive in terms of packet count. Another way to find this is, if you close that out, go to the I/O graphs and we'll show that.
Yeah.
So statistics. The I/O graph is hidden away on the statistics tab, and that's somewhat unfortunate because, boy, is this thing useful. So what we're looking at here is, we're looking at a graph of the traffic, and the beauty of that is that visually our eyes are a lot better at picking up on patterns if we see a graph versus a whole stream of packets where it's like, I can't make any sense out of this. So the beauty of this is that you can add more rows into this graph. So add us a new row in there, Ping.
Actually, Greg, give me 1 second. I'm just going to pull up another file that it's pretty neat to use for graphing.
Okay.
And I mean, unfortunately, again, for everyone here, we do know the files that we're using, so we're not going into it blind. But again, just to make a point, I/O graph here. We're going to add a line, as you said, Greg. Go on.
So and then you could do like the global broadcast was what I was going to do. So it's BACnet.dnet. If you want to do global broadcast, BACnet and then dnet. Destination network equals 65535.
Okay.
16-bit number. Yep. And then click out of there and make it a bar or something. And I like red or any of the bright colors. Try and make it show up better. And then, yeah, you can call it broadcast, sure. And then you'll have to enable the line after you click out of it.
My bad.
Okay. Yeah, that's the beauty of it. It saves them. Once you set them up, it remembers. So it goes through and processes that. And now what we've got here, well, yours is really low. The capture we had open before has got a ridiculous amount of broadcasts in it.
Yeah.
Your MSDP capture doesn't have that. We're looking at tokens. Yeah, that'll work.
Yeah. Actually, that's not the file I meant to use. Okay. That is not the file I meant to use. Okay, no worries.
Just close the graph and reopen a different file. Then it's no problem.
Yeah. No. Oh, I didn't grab that one. Give me 1 quick second here. You know what? Let's just go back to the one you were.
My circular network one will definitely it'll stand out on here because when the capture started, there wasn't a circular network, and I enabled it when the capture was already running. So just go to I/O graph. It should already have the right setup because we've already saved this.
Yep, there it is.
Waiting for my screen to update here. There we go. That's better. So those red vertical bars are BACnet broadcasts, and the y-axis scale is in packets per second. So you can see how, like at the beginning of the thing, everything's fine, and up to about 45 seconds in, everything's fine, and then all of a sudden the peaks start, and you'll see how high they get. They're at like 160 packets per second. That's a result of the circular network. So my point is that you can see by the traffic volume here that something abnormal has definitely happened over what might be normal for your particular network. and that the traffic's gone through the roof, and then it's like basically, yeah, we got a traffic problem. Then you start doing the analysis on the file to figure out what traffic problem do we have, which in this case led to the fact that it was a circular network.
Right.
So,
yes.
and you can add as many rows as you want basically to this filter bar in the graph, looking for different things. So it's exceedingly useful for looking for patterns, especially over a long-term capture. Sometimes if you have a capture that's an hour or longer than that a day, you know, you don't want to be scrolling through the list vertically of the raw packets because you're never going to see anything that way. So I look for abnormalities in the graph first and then zero in on that time on the actual capture and find out what's going on. In fact, if you pick on one of those areas on the graph, it'll highlight the packet in the capture for you, which is kind of cool too.
Yes, yes, actually, let me just delete this 1 second. Uh-oh.
Wireshark stopped working. Oh no!
Advanced troubleshooting right there.
Huh. I wonder what version is this, Ping? Go to help and about in Wireshark. I'm just curious. One thing for you Wireshark junkies like me is 221. Yeah, okay. You're not quite up to date. 225 is the most current. One of the things about Wireshark is the team that creates this tool, they keep cranking out new updated builds, like faster than every month. There is basically no point in upgrading to every one of them, but my advice to you is, notice how Ping's got 221. Every time there is an incremental upgrade like the 2 or the 2.20, the very first one out of the gate has got the new functionality, but it tends to crash more. And as the build number gets up in the last digit, the third digit, the tool becomes more stable and less finicky, I find. So I try to find high numbers in the last one, because you don't have to have the bleeding edge, especially for BACnet. You don't have to be on the bleeding edge. Typically, they're adding support for newer protocols, that kind of thing, into the tool.
Yeah, thank you, Greg. You were just coming back to something you were saying earlier, that if you use the graph, going on the bar, clicking on it will jump to that section.
Right.
Really nice area.
Which is cool, because if you see the point where all hell breaks loose there at about 50 seconds, you can click on it and it'll zero you in on that area of the capture, and you can scroll from that point and sort of see what happened here. So the graph's a very useful tool. I use that all the time. Do we want to move on to our next capture here, Ping?
Absolutely, let's do that.
So the next one was the duplicate BBMD one, I think.
That's right.
Because we're done with the circular network one. So we're moving on into another, I'm just consulting my own notes here. We're moving on into another area that's a common BACnet breakdown. So BBMDs are, it's short for BACnet Broadcast Management Device, but what it basically does is a BBMD acts as like an anchor for a particular IP subnet and is responsible for sending the broadcast from that particular LAN, like Ethernet LAN and MSCP, over to BBMDs that are on another IP subnet. This is how we go across the world or across the campus. It's basically the way to span IP networks from one location to another, make use of BBMDs. The problem with this is, especially in a multi-vendor case, if you have more than one vendor working on your particular site, BACnet vendor I'm talking about, the problem is that BBMDs are often a requirement, but if the different vendors and contractors are not synced up properly in terms of who's doing what, you can end up with a situation where there are two BBMDs on the same IP subnet. Now, in an IT sense, you might think, hey, that's great, I got redundancy. No, you don't, you have an explosion. Unfortunately, two BBMDs are not a good thing either, because they end up bouncing packets between them and duplicating all of the broadcasts. It's not the same as a circular network, but it has similar symptomology. When there's two BBMDs, you tend to have a really crappy network because there's a traffic overflow. So again, this is somewhat of a contrived lab exercise here. This problem, I don't want to give that impression. This problem exists in the world. It happens every day. But this particular capture that I'm making available to you guys, I took at my desk with a fixed set of Delta controllers where I could control the situation. So it does have duplicate BBMDs. What I want to do is point out that it's a problem, and then how do you use Wireshark to find out that you have that problem? Because like knowing that isn't much good if you don't know how to find it. So what we want to look at here is we want to make use of something that's in the BBLC. So open up on one of those broadcasts there, Ping. Yeah, you're on a Who Is right now, that's fine. Yeah, click on one of those guys and open up the BBLC. Inside of here, there is a function, which is basically when the BBMDs are communicating, the function is basically describing something about where this packet came from. It's saying that it's a forwarded MPDU that came from IP 192.168.11.54. I'm not worried about the IP address. What I'm interested in is the function number. So we can actually filter on that. If you go up to the top and put in the line at the bottom, BBLC.function equals 4.
Yeah, I'm just going to show because this time we got lucky because we have a packet that's a Who Is. So I could have just used a right click and apply a filter. But again, very often, if you're in the field, you're not as lucky as that. So if you have to, you go here. Nope, my bad.
Yeah, you gotta, yeah, BBLC, we need that one. Yeah, you got BACnet in there as your search criteria.
That's right.
So it's not giving you the proper list. You can put BBLC in and it'll give you the right one. This is another case where we have to use that funny BACnet virtual link control. The data we want to examine is not in the BACnet MPDU or BACapp APDU sections. Yeah, forwarded MPDU. What a forwarded MPDU is basically the packet came from not the BBMD itself or another IP device, but it was forwarded on behalf by the BBMD into this network. So now if we apply this, why this is a useful criteria is because these are packets that are basically being forwarded by the BBMDs. So if there's more than one BBMD on our subnet where the capture was taken, we would expect to see more than one source in Wireshark that is basically sending the same packet. Now, as it happens, in fact, let's just do another little trick. Can you go to View and change the time, Ping? The View pull-down menu?
Absolutely.
Right now, the time is in the capture time of yesterday, but go to seconds since beginning of capture. This is one really nice thing about Wireshark. You can change the time, the way it's reported. Sometimes if you're looking for a problem that you know happened at 8 o'clock, then you want to look at the absolute times. Other times, it's just basically since the time of the capture I want to look at, which is what I want here. Now scroll down to, I think it was 673, something like that from memory, again, the problem doesn't exist at this point. There's not duplicate BBMDs at the beginning of the capture, so there's nothing defined at this point. So if you start going down, that's when things are going to go a little bonkers again. Again, the IO graph would be helpful because we would see the traffic spike up. Keep going down a bit further. Because I know it was right in here when I enabled the whole thing. Yeah, that's good there. You just went past it. Go back up a bit. Actually, anywhere in there is fine. Now notice how, yeah, like that Who Is 200. You see how there is a Who Is 200 and it's repeated 3 times in our capture? If we look over at the source IP, we'll see that it started from 11.24, and that's true. That's actually where it came from. But then notice that the next 2 lines send it out again as 82.60 and 82.17, both sent to the same destination, which is a subnet broadcast. So I'm looking at packets 4260 and 4261 here in this capture as basically confirming that there are duplicate BBMDs, because there's no rationale for that packet as a forwarded MPDU to be basically being repeated by more than one IP source in my own network. It really only would come from one IP if there was one BBMD. So it's those 2 guys there, exactly, yeah. Turn the mark on for them.
I'm just going to summarize again what you just said there.
Sure, go ahead.
A duplicate BBMD in this case, you can see very clearly So I added a field called the IP field from the BBLC, which is the originator's IP address in this case. So we can see it comes from the same original device, this .11.24, and it's sent, so the destination is sent to 8263, which is broadcast, but the source is different. So the source in this case, the IP source address, is the source address of the BBMD device server, and so you see there's every device on this system, on this network, will now get 2 copies of this Whois 200. It came from one single source. It was picked up by 2 BBMDs, so BBMD 8260, right, and then forwarded it.
So those are the 2 devices, 82.60 and 82.17, you'd want to examine in more detail because they're both enabled as a BBMD right now, and that's no good.
Yeah, that's right. So I think one of the things you can look for here is, as I said, as Greg said, use the BBLC function for, which is for the MPDU. Again, the trick here, if you find a packet that has it, right-click on that, apply as filter. I like to take the field that makes it a little bit more obvious, right-click on that, apply as a column. So now I have a column that shows the source device, and then I kind of look at the source of the packet itself. So you can look at it through the human eye and see that these 2 packets are coming from the same place, picked up by 2 different BBMDs.
Right, right. I agree. So that's another common BACnet problem, especially in a multi-vendor network, to have this happen. Okay, so we're going to move on to your MSTP token disruptions.
All right, let's do that.
Next capture file.
Next capture.
We're switching gears here. The ones we showed you to this point are all taken on Ethernet. This particular capture, and we'll talk a little bit in detail about this after we're done with this capture, is an MSTP capture, not an Ethernet capture. And they look somewhat different because source and destinations aren't IP addresses anymore. They are MSTP MAC addresses.
That's right. So at first glance, actually I should just enable one corollization rule that is there by default, which is a checksum error. It's a very useful one. So at first glance, you can see on the right-hand graph, the vertical bar that Greg was mentioning, you already see some black lines. So that's a little suspicious right away. It's just a trick, right? Again, I'm mentioning. So scroll here. Where am I? Oh, here it is. So this packet here, because of corollization rule, I can tell you it has an error in it. So that's the first thing that should pick up your eyes. Keep going, Greg.
Yeah. Okay. Sure. So what we're trying to examine here is that if you have an MSTP network that's having quality problems, like reliability problems, it's working, but it falters, it recovers, it falters, the communication of the devices on the network are shaky, we can use Wireshark in this case too, because when an MSTP network falters, typically what happens is the token is lost and it has to be recovered basically. So the token that makes the network work that's going around between all the devices all the time has become lost or duplicated, and basically everybody is confused, and the network needs to be restarted. So that's how it recovers on its own. And during that recovery phase, there's a type of packet we can look for. And again, this is where we use the display filters. So what we're looking at on the screen right now are just tokens. So they're going from, 10 to 11 to 11 to 12 to 13 to 14 to 15 to 16 through all the different devices on there. When the token is lost, the controller will start to send out a packet that's called poll for master. Basically, it's looking for another master device on the network to give the token to is the idea. And if it finds that device will reply to poll for master. Now, what this means is, if your network is running stably and perfectly and there's no problems, you will not find a reply for poll to master in the capture because the network never faltered. However, if you have a network that's suspicious, if you go in here and look for its frame type is the thing we want filter on, and equals 2. The number
Again,
2 is, the number 2 comes from the fact that frame type 2 in MSTP is known, see it's right there, is known as reply to pull for master. So in this particular capture here, which is probably not actually all that long, there's 52,000 packets, but that's not uncommon for MSTP. This capture is probably not that long. And we have 3 replies to pull for master in here with significant time between them. So this means this network is faltered 3 times during this capture, indicative of problems. Also, if we loop back to what Ping was showing a minute ago about the CRC, the error, the packet that was in yellow was black, and then when you expand it, it's in yellow. That's because each MSTP packet contains a CRC, which is cyclical redundancy check, to verify the integrity of the packet. And there were packets that were failing the CRC check. That's what Ping had found first. So when you have a failure of the checksum and reply to pull for master, you've got an MSTP network that's hurting. So if a CRC check is bad, it means more than likely there are wiring problems in terms of quality on the network. Stuff like it's not terminated properly, there are too many devices, the wire's too long, the wire isn't the right type. These sorts of issues, like it's unshielded, all those sort of issues on MSTP would lead to this kind of a problem occurring. But we can see how the network does run stably for a period and then falters. So it's very unlikely that this problem is caused by a bad device, like one device gone bad, because even here you can see that the if we check the reply to pull for masters, I don't think it's the same device each time it comes up. In any event, the CRC check basically cinches it as it's not likely to be a single device causing the problem. We're talking about electrical issues, not logical.
Yeah, much harder to find. So you can see here, so the packet in dark red, so packet 30,512 is the reply to pull for master. And you can see earlier, those 2 packets are black, which have a CRC error.
CRC errors in them.
Yeah, these packets were captured by Wireshark, but they were likely tossed away by the receiver because they have an error in it. So they're not trustworthy.
Yeah, the receiving device would have thrown this away.
That's right. So you can see here the error here.
So, was there anything else about this capture you wanted to show, Ping?
No, not really. No, not really.
Okay. So we got some additional, we got some additional Wireshark tricks here that we were going to bring up that are sort of outside of our individual captures of common problems. And one of them was capturing MSTP, which is a bit of a problem because you're talking about RS-485. It is possible to do this now, though, but what you need is a USB. If you go to Amazon, for example, look up USB to RS-485 converter. So basically what you're going to do is have the RS-485 tied to the converter, and the converter has USB, which is, of course, connected to your computer. And Wireshark in version 2 has a driver that will allow you to capture off USB. Yeah, this will find it, I'm sure. They're not an uncommon device.
Yeah.
They're not an uncommon. There's one for $6.99. I mean, how can you go wrong? It's even got screw terminals on it. So,
yeah, exactly.
So real easy. So you can patch into an RS-485 network directly. Like if you're looking for a token problem, that kind of a thing, token handling, you really have to capture at the MSTP level. You can't capture at the Ethernet level because it's not going to show you anything. If you think all that's too much trouble, talk to Ping about contemporary controls because they've got an agreement with those folks. Right, Ping?
Yeah. So contemporary controls, and actually I can tell you also, we're working with a few other manufacturers. We're encouraging manufacturers to add capture functions into their MSTP routers because we do know that capturing the data is a first phase that's a little bit difficult. But the contemporary controls has a router called the BAS router LX that have a built-in capture on their MSTP side of the router. So a simple little tool they can use to capture things on the MSTP side. Yeah. Okay, let's move on.
I'm going to
Great.
jump back on.
Yeah.
Oh, hi, Monica.
Hi. That was a pretty intense, fast and furious webinar. So I know you guys have a couple more tips, and that's really awesome. If people do have any questions, put them in that question box. We want to make sure that we get them answered. So I actually have one that I'm going to share with you guys, and then we can move on to some tips or more questions as they come in.
Yeah, that sounds good. So if the questions come in, we'll intermix some more tips in amongst them if there's time.
Yeah, so this is more of a, not a technical question, but it's, Adam is wondering, do you offer an on-site class for BACnet troubleshooting training that would be more detailed? So I'm not sure if that's Delta or Optigo focused, but we can take it both ways.
Go ahead, James.
We've been asked several times. We haven't done anything like that, but if the industry is interested, I'm sure we can put something together. Yeah, it would take. I mean, to be honest, just like what Greg told me yesterday when we were practicing. Unfortunately, Wireshark. Well, fortunately, Wireshark is free and it's extremely powerful. But unfortunately, Wireshark is one of those things that if you don't use, it's hard to get good at. These are tricks and tips that you have to use. I mean, Greg uses it every day multiple times, so obviously he remembers that a reply proposal master is type frame 2.
Yeah, like how do I remember that, right?
That's right, that's right. So we'd be glad to put something together. I can maybe talk to Greg and some other folks in the industry that I know are very good at it. We can see if we can offer some courses. But again, this is what this is as a start. I think the first thing we can offer is, send us an email if you have a question. We'll be happy to help you if you have some questions. We did do a basic troubleshooting webinar about 6 months ago, I think.
Yeah,
and it's recorded. It's available online. So those who want to just get started, take a look at those ones. If that's still not enough, send us an email. We'll see what we can do about that.
Great. So did you guys want to review some more of your tips, some capture filters and capturing options?
Yeah, just some basic ones.
Sure, capture filters.
Yeah, that's right.
Yeah, go to the options there, and we'll just talk about what's in there on the options list. One of the sort of problem areas in Wireshark is that if you just say go and start capturing, it's going to capture every packet it can see. And there's a few problems with that. One is that, like, if you're on a remote desktop section, you're gonna be capturing all the remote desktop packets too that have no value to this conversation. Also, if you're on a shared network that's not just for controls, you got to watch out because you're going to be capturing traffic that might be sensitive. So the IT guys at that site may not be happy that you're capturing their traffic. So it's better if we restrict the capture down to only capturing that which we're interested in and get rid of all the other. Now, it'd be lovely if you could say capture BACnet, but you can't, unfortunately. The capture filter is a different syntax than the display filter. It's a much lower level thing. It has to be able to do this very fast. So it can't fully decode the packets as they're coming in. So what we can do is we can say, well, we're looking for a BACnet Ethernet problem, in which case we don't want to have any IP packets. So the way you do that is you write not space IP. So if you put not IP, I don't know why it's saying red there, because I don't know why it's in red.
Oh, no, because I don't have an interface right now. It's because I don't have an interface right now.
Yeah. You can also go like not TCP, for example. If you're only looking for UDP packets of BACnet or, there we go, or Ethernet packets, I often capture with not TCP. So it throws away all the TCP packets that are directed, basically, which are high volume, like high packet sizes. This also has the advantage of making the capture file itself a lot smaller, so when you save it, it's a smaller file to begin with. But even then, this is not always enough. So go over to the Output and Options tab there.
Yeah, just quickly, one other one is to use UDP port range, or just port.
You can do a range.
Yeah.
Yeah, you can put in there a range of, right. So you're basically going to capture UDP, but only inside this range. So it gets rid of all the other stuff that you wouldn't be really looking for anyway in a BACnet problem case.
Okay.
So the other part of this is that that's all well and good, but the problem is if you're going to let a capture run like overnight, like you're looking for an extended run time in order to capture a problem that happens once a day or something like that, the trouble is you can't let it run and run and run and run and run and plow it all into one file in real time, because your hard drive will fill up, basically, will eventually happen. So what you can do with this is, exactly, you can create a new file after so many K or so many seconds, or you can change it to minutes or hours. This is a very useful thing. I use this frequently. And you can use the ring buffer thing with, like, 5 files or whatever. So what it does is it basically will have 5 files or 10 files. Let's say they were 1 hour long each. If you set it up that way, then you'd have basically, you'd have a continuous running capture of 10 hours right now into 10 different files. And they start overwriting after, like, at hour 11, it overwrites hour 1, and hour 12 overwrites hour 2, and so forth. But it allows you to keep going and have the capture keep running. So when you finally see the problem, you can go, hold everything, let's get the file from the last hour. And you'll actually have it. Because you can't run a continuous capture otherwise.
Yep.
So they're very, very useful little sub-elements of capturing to try and keep the file size manageable so you can capture for a longer period of time. That's basically the trick.
Good.
Great. Quick question for you guys. What output format is better or best?
In Wireshark?
Yeah.
You're asking, I suspect, relevant to the screen we're looking at right now.
I would imagine
PCAP format.
all I have is that.
Okay, that's fine. I can answer that. The PCAP format there, that is the original format used by a tool called tcpdump, which is also known as WinPCAP. Whenever you install Wireshark on a computer, at the end of the process, it says, do you want to install WinPCAP? And you probably know, what the heck is this for? That's the actual tool that talks to the Ethernet NIC on your machine to capture the packets. As it captures them, it's handing them up to Wireshark. And its native format was PCAP, packet capture. And now that's all fine and dandy, but the thing is, Wireshark added a lot of additional capability in terms of what it can do with a packet that tcpdump and WinPCAP never had, because they weren't really analyzers, they were capture tools. And so Wireshark created this pcapng, which is next generation, it stands for. It stores additional information in the packets that the PCAP format doesn't have about the MAC addresses and so forth. So there's additional information that Wireshark knows that it's going to save in the capture file that a PCAP file would strip out. Most of the time for BACnet, this wouldn't be relevant at all. One thing I will tell you is the pcapng files are not any smaller than the PCAP files. In fact, they're a bit bigger because they're storing more information. So don't look at it as a size thing. There is an option when you do a save, though, when you go file save or file export. There is an option there to save with gzip. It's not a big deal. All it does is basically compress the file, but that's worthwhile if you're going to email it to somebody, because just go save as their ping. Like, we're going to save this capture again, which we already have, but
It's a little bit
and you'll see at the bottom it says compressed with gzip. So basically what this will do is it'll pre-zip the file up as it's saving it, which will compress the file size a lot. See, we've gone from the 3.4 meg file there. Is that the one we had open?
No, I think it's a duplicate BBMD, I think.
Okay, so 3.6 megs down to 714K for the same file. So if you're going to email it to somebody, this is a helpful thing because it shrinks the file quite a bit. And of course, the other end can open the file, you can unzip it, blah, 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 blah. So, yeah. So I wouldn't worry too much about the pcapng thing. It's more relevant to other protocols than BACnet.
Yeah.
Okay. Perfect. Well, I know that people have meetings to get to and things, so I don't want to go over time. But Greg, Ping, thank you so much for this crazy amount of information. I know that a few people are a little bit overwhelmed by how much information they just got.
Well, you told me you wanted advanced.
I know. That's what you guys signed up for, so stop complaining. No, but I've had a few people ask if it will be available afterwards. So this whole webinar has been recorded, so you are definitely going to be able to go back and you have all the files, so you can work through it and or send it to your friends who you think might need it. And of course, because I have to give this plug always, a lot of this stuff can be found by Visual BACnet as well. So That's the product that we at Optigo make. And so if you have any questions about that, we're always happy to discuss that more. And a couple people did ask questions that we didn't have time to get to, and some that were vendor specific and things. So we will get back to all of your questions. We just want to make sure that we get all of you out of here on time. So Ping, Greg, thanks again. And we look forward to hopefully most of you joining us on our next webinar.
Thank you, Greg, again.
Well, thanks, folks, for joining us. It's fun for me to actually go through this in sort of a more general sense instead of a specific, particular problem sense. So, good time.
Great.
Have fun with Wireshark or Visual BACnet.
Yeah, enjoy. Thanks.
Thank you, everyone. Have a good day.